Hi everyone, this is about properties of ionic compounds. We are still discussing ionic compounds. By definition, ionic compounds are formed by the transfer of electrons. So metal gives an electron to non-metal. Metal can give one electron to a non-metal. Metal can give two electrons to a non-metal. Oxygen has six, so oxygen can take one from both from the calcium, so it will be positive 2 negative 2. So then this takes it becomes positive 1 negative 1. So metals form positive ions or cations, and non-metals form negative ions or anions. They are formed by the gain of electrons, and the process is called reduction. You have to know the definition of reduction. Means gain of electrons, and loss of electrons is oxidation. So oxidation reduction is happening here for metals and non-metals. Ionic bonds form when metal atoms transfer the electrons to non-metals, forming ions. And then in the crystal lattice, the positive ions are surrounded by the negative ions. So if you look at it, sodium chloride crystal structure, each positive ion is surrounded by negative ion, and each negative ion is surrounded by the positive ion. If you look at it, this is surrounded by the positive ion, and if I look at each positive ion, it is surrounded by the negative ions. So negative ion, same thing I was saying. So this is a 3D crystal structure, and they're very strong bonds. Okay, they're formed. These are ionic bonds. So since ions, you see here, each ion is each positive is surrounded by negative, and each negative is surrounded by the positives. So let's look at this. Negative is surrounded by the positive, or positive is surrounded by the negative. All right, so this is called a lattice structure, means a repeating pattern from positive and negative. Okay, so it repeats itself, as I'm saying here. If you look at it, it is a repeating of structure. So this is positive, and this is called lattice structure. The ionic compounds have a very strong lattice structure, and they are together by using formula units. So we do not, they don't become individual ions. They're usually together in the formula. Okay, so you do not see individual molecules. They're always bonded together. So that's why we don't use the word molecules for ionic compounds. We use formula units for ionic compounds. So this word is very specific to be used for ionic compounds. So based on this, because of the positive and negative nature, positive ions, negative ions, they're holding each other very strongly. They have a strong crystalline lattice structure. They have very distinct properties. Okay, so because of the strong bonds, they have very high melting point and boiling point. All right, they have very high melting point and boiling point. And all of the ionic compounds are solid at room temperature. They're not gases or liquids. They're solid at room temperature, and they have high melting point and boiling point because of the very strong crystal or lattice structure. They're hard, okay, brittle solids. They're brittle means they can break. They like, if you break it, it will not be turned into sheets, so they will not bend. They will just break. So hard and brittle structures like calcium chloride, sodium chloride, or things like that. Hold on one second. I don't know why it's giving me such a hard time. Important properties. Ionic compounds are soluble in water. They're good electrolytes because they have positive ions and negative ions. So they are good electrolytes. They are soluble in water, and they can dissociate in water. And because they can dissociate in water, they are good electrolytes. And what does that mean of dissociation? Means they can split into ions. Okay, that's what the dissociation is about, that they can split into ions. Okay, so it is very important characteristic to know that they're soluble in water. Ionic compounds soluble in water, and they're electrolytes. But when they are electrolytes, they can conduct electricity. So they can conduct electricity, but you have to know that they conduct electricity only when they are melted or when they are dissolved in water. They are not electrolytes, so they don't conduct electricity when they are in solid state. So you have to keep it in mind. Don't get confused that ionic compounds overall are good electrolytes. Yes, they are, but they have to be dissolved in water or they have to be melted. So when they're melted, their electrons are free to move around, and they can carry the electric current. Or when they are dissolved in water, so they dissociate. So let me explain what the dissociation is. Dissociation means you take an ionic compound. So what is an ionic compound? A metal non-metal combination. That's an ionic compound. When I dissolve it in water, okay, I don't write a chemical equation. That means that when I dissolve it in water, AQ means it is dissolved in water. The water is going to split it into positive ion and a chloride, negative ion. And this process is called dissociation. Okay, this process is called dissociation. So I will write it again. I have sodium chloride, AQ. AQ means it is dissolved in water. So anything that is when dissolved in water, that means it is in positive ion and it is in negative ion. And this process is called dissociation. So if I have CaCl2, if I have a solution of it, that means it is present as Ca plus 2, and I have 2 of the chloride ions because I have 2 right here. So I have 2 chloride ions. So this is called dissociation again. So when ionic compounds are dissolved in water, they turned into ions. And then these ions carry the electrons for the electricity. So you have to understand the term here, important properties, that they are soluble in water and they're electrolytes and they dissociate in water. That means they separate into the ions and conduct electricity when ions are free to move around. So when they're dissolved in water and when they are melted. So these are the ionic properties. Again, you have to understand. They have loss of electrons, gain of electrons, cations, anions. They have a very strong crystal lattice. They have high melting and boiling points. They are solid at room temperature. They are hard and brittle, and they are soluble in water. And they're good electrolytes only when they are dissolved in water or when they are melted. So these are the properties of ionic compounds. All right, everybody. Thank you.